You're listening to the Banana Data Podcast, a new podcast hosted by Data IQ. I'm Trevani.
And I'm Will.
And we'll be taking you through the latest and greatest in data science without taking ourselves too seriously. Today, we're going to explore who's to blame when our algorithms fail, accessible healthcare through AI, and Epsilon greedy multi-armed bandits, as well as the status quo of AI reporting.
Okay, so the first article I want to talk about comes from technologyreview.com by an author named Karen Howe. And the article is called When Algorithms Mess Up, the Nearest Human Gets the Blame. And so in the introduction to this article, Karen talks about earlier this month, someone sued an investment firm because they lost $20 million, and those investments were controlled by algorithms, not individuals. And so the theme of the article is when something goes wrong, and that something that has gone wrong is the result really of an algorithmic accident or an algorithm-controlled accident, not like a human-controlled accident, who gets blamed? And so I think it's a super interesting question, one that we haven't made a lot of progress with yet, and one that we need to think about going forward.
Oh, yeah, definitely. Right, because the first thing I think of with that investment article or the investment lawsuit is whose fault is it for that algorithm? Is it the person who made the algorithm, right? Is it the team? Is it the decision maker who said, all right, put the algo in production? Is it, the VP of data science? Is it the head of the hedge firm who says, we're gonna use algorithms to dictate our investments, right? So where's the chain of command, and how far deep do we go? Do we say, well, it's actually this statistician who's been dead for 100 years. It's his fault because he's the one who invented the algorithm, right? Where does the buck have to stop?
Yeah, no, that's a great question. And I think in the article, the author makes the point, as you can kind of tell from the title, that too often it's the person who's just standing there, who's standing closest to the accident. So again, another example they give is in 2018 when a self-driving Uber car struck and killed a pedestrian. Yeah. So in that unfortunate instance, the author notes how there was some backlash against Uber, right, because the company broadly or some department of the company was responsible for the self-driving technology. But there was also backlash against the individual who was sitting at the steering wheel, who was letting the self-driving car drive, but who was, supposed to be, in some sense, or at least people felt as though they were supposed to be overseeing that self-driving. And so the author states, and I kind of agree, that just the person who's sitting there, literally or figuratively, right by the scene of the accident, to your point, they didn't design the math. They didn't put this algo into production. So should they be held accountable? I don't really think so either, but I can see it's maybe natural you want, someone to blame, and they're right there. But I think we need to do better than that.
Well, I think a good analogy too, right? And she brings this up is sort of the plane and automobile industry, right? When a plane crashes because something went wrong with the mechanics inside, or a car's brakes fail, are we really blaming the pilot? Are we really blaming the driver? Or are we saying, hey, airline, fix it? Or, hey, car company, fix this? And so do we hold our AI to that same standard? Or do we say, okay, this is a totally different kind of situation? Yeah.
And to me, again, kind of a theme of this podcast is we need clearer guidelines. Yeah. So to your point about brakes, when we drive a car, we kind of have the societal understanding of what the driver should do and how the mechanical brake system should work. And if there's a brake failure, it's not the driver's fault because the driver was doing their job and the brake failed. But so when autopilots or self-driving cars fail, what are the expectations or what are the guidelines of what the person should do versus what the system should do? And as these systems get more and more intelligent, I think, we might assume that we have to do nothing. And maybe that's the case, but realistically, I think we're not there yet, and we need to be clear about what humans should still be expected to do.
Yeah, I mean, even pilots are still trained on how to fly a plane. It's not like sit down in this seat and push this button, right? So they still know what's going on internally. They still understand what decisions are being made and why. And they have the ability to maybe override unless that override fails. But I think what's more important here is the idea of governance, right? Because we do regulate the car industry. We regulate the airline industry.
Yeah, that's true.
We have protections in place for food and health and medicine and everything. Why don't we have protections for AI, right? Where is that discussion happening? Why isn't that happening at a larger scale? And how would that look?
Yeah, no, I think kind of some high quality control board makes a lot of sense. So
I'll happily sit on that board. Will.
You could sit on that board, cool. And then we also need some education for the individuals who are controlling these systems at the low level on the ground. And just do those two things, and I think we're good.
I mean, if we keep looking at our AI as like sort of a magic box and
Yeah.
telling people, here, just let the
gonna fix
magic do
everything.
it, we're gonna run ourselves into the ground,
Yeah.
right? And so making sure that it's not just about, oh, data science is like progressing and we're like creating great new algorithms, but also people who don't work with data science every day being able to understand what it means, being able to like put it into some kind of context is super critical if it's going to be a part of our lives.
Yeah, just AI is a technology just like there have been other technologies in the past, and so we should be treating it more like that. I think that's a great point.
So I think it's important to have these kinds of conversations, Will, because eventually AI is going to be a part of our day-to-day lives. I mean, it already is, but it's going to be a part of our lives in a much more robust way. And so one example is actually Google has trained its AI to predict lung cancer. And so this is an article from Engadget. And the article explains that Google basically used an AI model to train this algorithm on images of chest scans, CT scans. And then it tested the results against actual real radiologists. So it ran the algorithm, created the algorithm, and then examined like 45,000 CT exams and said, okay, this person probably has lung cancer, this person probably doesn't, whatever. And checked those results against what a radiologist would think looking at that same scan. And so it found that the Google's AI for detecting lung cancer found 5% more cancer cases than the radiologists, but it also reduced false positives by 11%. So it's not like it was just saying everybody's got cancer, right? It was also saying, hold on, not everyone that you think has cancer does have cancer. And
kind of for a binary classifier, better in every sense.
Right, yeah. It's sort of like this, like, we talk about in data science a lot, the bias variance trade-off, right? Do I want to be making sure I pick up all of my positives, even at the risk of getting false positives, or do I want to make sure I pick up all my negatives at the risk of getting false negatives? And in healthcare, we often say it's better to err to false positive because you can always run another test and make sure. But when it's a false negative and you miss something, the results are much more disastrous. Yeah. So I think it's super great to see one of these applications where actually the algorithm is helping and improving in some ways.
Yeah, I mean, this is something that I think we talk about a lot in our work. For all the listeners at home, and maybe this will be another in English, please, next time. But this idea of bias, variance, and then particularly with regards to binary classifiers, things like precision, recall, and F1 scores. So maybe we'll do it in English, please, about F1 scores next time. But this idea of getting it right, but not at the expense of just spraying yeses everywhere, essentially, is important. But this sounds like a great application of AI ML to me. A nice classic supervised learning example where presumably they know historically whether those CT scans corresponded to lung cancer or not. Just let the AI do its thing. And by the AI in this case, I assume it's some sort of deep convolutional neural network, that sort of.
I mean, they didn't go into the specifics, but I actually want to push back. I wouldn't say let the AI do its thing.
Yeah.
For me, I think it's let the AI help doctors do their thing, right? I would say, okay, the radiologist here says it has the person has cancer, and the model's saying no, it doesn't. So maybe that radiologist is going to take a second look, right, and actually detect something, or take a second look and be like, no, model, you are wrong. I know what I'm doing here.
Touche,
right? So on guard.
I mean, I think that, and this is something again, kind of data science 101 or machine learning 101. Oftentimes, people find and have found empirically and kind of theoretically that these ensemble models tend to perform well. So an ensemble model is when you have model A that's a predictive model, and then model B is a predictive model, and model A and B are somehow different in their structure. So they're both trying to predict the same thing, but the way they come at those predictions is kind of different. And so if you ensemble, which is just a fancy word for combining models A and B, you tend to get even more powerful predictions. So again, touche, I think your point about ensembling the AI, the doctor, that seems...
Ooh, I love that.
Seems perfect.
The human AI ensemble are going to be like robo-cops.
Yeah, I think the term for this, and I'm not an expert and I'm definitely not a great player, but in chess, now they have what's called centaur chess. Are you familiar with centaur chess?
No.
So it's just this idea of, right, you saw Deep Blue and these other computer chess players, quote unquote, really triumphing. And then I think for a short period of time, centaurs were the best chess players in the world. So centaurs were basically humans who had the access to an AI or a computer system. So essentially, you and I would be playing, and the computer would be recommending to me like the top 3 moves that the computer thought were good. But I, as the human, would insert my own judgment. And for a while, I think that was kind of the ultimate in chess performance. Now, unfortunately, I think it's actually just, or maybe unfortunately, I think it's actually just AI.
All right. Well, I mean, chess and lung cancer are not quite
A little bit different.
Not quite apples to apples. Yeah, and I think what's important about this too is that they mentioned that it creates a lot of accessibility. So the article also mentions that only 2 to 4 people who might need to be screened for lung cancer in the U.S. actually get screened, right? Because it's a costly procedure. There's a lot of effort and time that goes into it, and so they actually reference some other stuff that's happened, I think, on the Google front where eye testing can be done. You can pre-test for blindness using certain algorithms. And these machines and the algorithm is actually really simple and easy to roll out. And it's actually started rolling out in India, where people won't have as much access, right, or might not have as much access to that kind of technology. And so bringing those algorithms to the field where people need to be able to figure out, oh, am I going to go blind? Can I prevent it? I think it's great.
Yeah, this is nice. I think we're providing some balance. Usually, ironically, for a data science podcast, I find that we can be, doom and gloom, and that the algorithms are not providing accessibility or they're providing bias, which we know they can. But in this case, yay rah rah, algorithms and centaurs.
Yeah, I mean they're doing well, and we just won't talk about the Uber thing anymore, I guess.
Yeah.
All right, this is the part of the show where we talk about complex data science topics in English. And today's topic comes in as a request from a listener. Grant wants to know about Epsilon greedy multi-armed bandits, which sounds to me like the Hamburglar got a PhD. So I'd love for you, Will, to explain Epsilon greedy multi-armed bandits in English, please.
Yeah, so last time we spoke about multi-armed bandit algorithms, and just as a refresher, these things provide us with a decision method when choosing between different strategies, where each strategy has a various and unknown reward distribution. So refer back to our previous podcast if you want more information kind of broadly about what multi-armed bandits are and what they do. But so the question we had was about Epsilon greedy multi-armed bandits. And so again here, this idea of an Epsilon greedy multi-armed bandit helps us determine how we should trade off between exploration and exploitation. So with an Epsilon greedy multi-armed bandit, you pick some small number, which we call Epsilon. So maybe that number is like 5%. So then what you do is you pick in this case, the slot machine arm with the highest reward distribution, and you keep picking that slot machine arm that you've seen thus far has the highest historical reward distribution. So say I pick slot machine 1 and it returned $10. And I picked slot machine 1 again and it returned $20. Now my running average of returns for slot machine 1 is $15. So I'm going to keep going back to slot machine 1, and I'm going to keep track of the running average of rewards from slot machine 1. But where that epsilon comes in is, in this case, we said epsilon was 5%. So 5% of the time, I'm going to take a random action. I'm not going to exploit. I'm going to explore epsilon percent of the time. So maybe, my random number generator tells me that it's time to explore, and I actually check out slot machine 2, and I pull the lever on slot machine 2, and I find I get a reward of $50. So now I'm comparing an average of $50 for slot machine 2 to an average of $15 for slot machine 1. So the next time when I go to exploit, which slot machine do you think I'm going to exploit?
2.
2, exactly. So the running average on 2 is higher than the running average on 1. So now I'm going to keep exploiting 2 until, again, epsilon percentage of the time, i.e. make a random shift, or the running average for slot machine 2 falls below some other slot machine that has a higher running average.
And that's the greedy part?
And that's the greedy part. So usually I'm greedy. Usually I'm exploiting.
I know, Will.
Fair enough. Usually I'm greedy. Usually I'm exploiting. But every now and again, epsilon percent of the time, I explore. And this is kind of the gist of it. There are many more sophisticated applications or methods here. But that's basically how epsilon greedy multi-armed bandits work.
Cool. Thanks for explaining that in English. So this last article is called No, This AI Can't Finish Your Sentence. And essentially it's telling us about the research and the reporting that is coming out against sort of modern coverage of AI, right? So a few weeks ago, the New York Times published an article called Finally, a Machine That Can Finish Your Sentence. And that was actually sort of incorrect. So, a team of researchers at the Allen Institute for Artificial Intelligence and the Paul Allen School of Computer Science at the University of Washington did some research on the supposed AI that can finish your sentence, and they found that they could actually stump this AI, and it hadn't actually learned sort of natural language inference or how to actually finish sentences, but rather how to understand stylistic traits in a data set to make a best estimate.
Yeah. So I had a chance to check out this article as well. I mean, I think kind of the way AI, ML is covered in the media. So they're taking a swipe at the New York Times. The New York Times is claiming AI's model can finish your sentences. And now they say, no, they can't finish your sentences. I mean, as we all know, reality is not black and white. And so I think everyone's just being a little bit too extreme here, as far as I see it.
Yeah, I mean, well, so the way they went about sort of proving that this AI, so the AI is actually made by Google. So Google did some great lung cancer stuff, but they also tried out this thing called BERT, right? And essentially BERT is able to take a sentence and make a best judgment of what the next sentence might be. And they do this with captions or, answering questions to wiki questions or whatever.
Yeah.
So the researcher said, look, okay, if you give BERT, a caption or something to finish, it's going to just try and find the answer, right, of a set of 4 choices. It's going to find the answer that seems to most closely align with what the style and the words are in the question. So to fool BERT, they actually generated new answers that were indistinguishable from human answers, right? So they had a bunch of random videos. They show these to humans. The humans write a caption for the first frame and the second frame. And then using a neural network, they generate fake second captions and embed the real human caption into the 4 choices of the fake human
test, yeah.
Right, for the multi-choice test. For the four choices, one of them has the real human answer. The other 3 are answers or captions that have been generated by a neural network. And BERT actually kept choosing the ones that were generated by computers.
Which are wrong.
Which were wrong, because they weren't choosing the actual human-generated one. Or BERT wasn't choosing the actual human-generated caption. And so it's just funny, the article states, they used a neural network to fool a neural network. And it's hilarious if you think about like AI, pitting AI against one another in that sense. But I also think it's important to think about, when we try to make these claims, as you're saying, extreme claims of, oh, we can finish sentences or no, we can't finish sentences. Maybe it's important to be a little bit more distinguishing about what we're trying to actually say.
Yeah. I mean, I think, again, another potential in English, please, as well. I think, general adversarial networks or GANs are huge in this space because here it seems like the Allen Institute maybe was kind of taking a swipe at Google, but also I'm sure more charitably towards them, the adversarial network that they use, helps us get better. And by pointing out flaws in BERT, they're all just advancing science. So that's very cool. But again, this is not really a surprise to me either. If you're working in the space, and I wouldn't claim to be, on the front lines building models like BERT, but if you do work in the data science ML space, I think we both know, natural language has a long way to go. So there's some cool stuff that's been done. Again, people at home, listeners at home can check out word embeddings. And so BERT is essentially, a hyped up word embedding model. And that's pretty cool in that it can take words and put them into space, put them into like an n-dimensional space, if this is all Greek. We'll come back to it later. But in general, if you think about the space of concepts and words, translating language to math is just really, really hard. And so the fact that the Allen Institute was able to say, hey, look, BERT is really flawed, like to me, it's not really a shock. We still have a long way to go to train computers to really understand what we mean when we write and type.
Yeah, definitely. I mean, we all like to sit here and talk about AI as like advancing and all these things, but it is still very much a work in progress, right? Even the lung cancer stuff. I'm sure they're not about to unroll lung cancer AI to replace all radiologists or whatever it is, but rather it is something that's a supplement. It's something that they're working on to develop more and more. And I'm sure they're reevaluating their models for BERT. I'm sure they're trying to figure out the best way to move forward. But natural language processing is hard because human inference is hard to teach to a model, right? Like the inferences that you and I have built in our minds are, they're complex, and we're not going to build out little brains that can do this.
Yeah, maybe at least not yet.
Not yet. Yeah.
I did think this was striking, though, because it does make me think about my recent experiences using Gmail. Have you experienced the sentence complete?
Yeah, it's...
And so I have to say, the Allen Institute's talking about how BERT struggles to predict the following sentence, right? So given sentence A, what's sentence B? That is indeed a challenge. But I have to say, Gmail is doing a pretty good job these days when I start a sentence of anticipating how I plan to finish it. A little bit creepy, but I have to say, I'm sometimes pressing tab and just using the Google suggestion. I'm guilty.
I know, but then I feel bad because I'm like, no, I'm giving you more. Like I'm telling you, and it's funny because it'll actually pick up on my style, and I think that's an example of that stylistic data set that they talk about in this article, right? Because you and I probably have different writing styles. We definitely do, and I know that when I'm writing, I'm seeing words and methods that I, that sounds great, or that sounds good, or let's find a time. So the ways that I speak, I can see it picking up and auto-suggesting it. And then it becomes this feedback loop because I'm like, yeah, that sounds good. So tab, let me just use it. And then all of a sudden Google's like, no, so you really talk like this. So it becomes this weird spirally feedback loop. But in some ways, yes, BERT is doing the job it's meant to do. In other ways, AI reporting is not doing the job that it's supposed to do.
Yeah, I think, the one takeaway I have broadly from this is that AI reporting, I think, should be a little bit more subtle in the way it approaches things. And then, of course, NLP, we've made some progress, but still a ways to go.
Cool. So we got to hold companies accountable. We got to hold journalists accountable. We got to hold ourselves accountable. There's a lot of accounting to do.
Yeah.
Anyone who's a CPA, come find us.
You can find a good job in the data science space. Exactly. Very cool.
Cool. Great. All right, before we sign off, it is time for my favorite part of the show, where I get to tell you a crazy banana fact, because after all, this podcast is called Banana Data. So, Will, did you know that bananas actually float in water because they're less dense in comparison?
I had no idea.
Yeah, so next time you go swimming and you forget your floaties, wrap a couple bananas around your arm, you'll be fine.
Will do. Before we go, I wanted to give a brief shout out to Dataiku's upcoming conference, Egg NYC, which will be obviously in New York City on June 20th, and focus entirely on the human side of AI, which is definitely a big theme of this podcast. We'll have speakers from a diverse array of organizations, such as Wired, GE, and Twitter, so please come check it out.
Check out the link in our show notes to register.
That's all we've got for today in the world of Banana Data. We'll be back with another podcast in 2 weeks, but in the meantime, subscribe to the Banana Data newsletter to read these articles and more like them. We've got links for all the articles we discussed today in the show notes. All right, well, it's been a pleasure, Tiernan.
It's been great, Will. See you next time.